This video is about solving multi-step inequalities. We're going to use the exact same steps to solve multi-step inequalities that we use to solve multi-step equations. First, we're going to distribute if we need to. Then we're going to combine like terms on one side of the inequality. Then we're going to get all of our variables on one side of the inequality. And then we're going to solve the inequality. The real key here is when we solve the inequality, don't forget that if you multiply or divide by a negative number, you must flip your inequality sign. And then we're going to graph our solution. All right, let's use this example. 6x minus 7 is greater than 2x plus 17. I don't have any distribution. I don't have any combining like terms. But I do have variables on both sides. So I'm going to move those variables by subtracting my smaller one from both sides. I'm going to subtract 2x. And I end up with 4x minus 7 is greater than is greater than 17. Now, this is just a two-step inequality that I'm going to use inverse operation. I'm going to get rid of my addition and subtraction before multiplication and division. So I'm going to get rid of the minus 7 by adding 7 to both sides. And I get 4x is greater than 24. And then I'm going to get rid of the 4, which is attached by multiplication, by dividing. And I'm going to say, hey, did I just divide by a negative? No, I did not. So I do not have to flip my inequality symbol. And I get x is greater than 6. To graph that, I would put 6 in the middle. And since it does not have an equal sign, I'm going to use an open circle. X is greater than is shaded to the right. Do not forget, if you multiply or divide by a negative number, you must flip your inequality symbol. All right, let's take a look at this one. First, we do have distribution. So I'm going to distribute that negative 7. And then I'm going to say I don't have combining like terms. I don't have variables on both sides. So now it's just a two-step inequality. I'm going to subtract 21 from both sides. And I get negative 7r is greater than or equal to negative 34. To get rid of the negative 7, I'm going to divide. That's my inverse operation. And I'm going to say, hey, did I just divide by a negative? Yes, I did. So I have to flip my inequality symbol. So now it's going to be r is less than or equal to 34/7. And I'm just going to leave that as an improper fraction because it will not reduce to a whole number. So when I put it on my number line, it's going to look like this. But I'm going to go ahead and put it in my calculator to get the decimal equivalent so I can see what numbers go on either side. So 4.9, I'd have 4 on the left and 5 on the right. It is going to be a closed circle because it's less than or equal to, and it's shaded to the left. Now, what if I get something like this? Well, first, I see some distribution, so we got to take care of that. So then I get 6x minus 5 less than or equal to 6x plus 40. Notice that there's a 6x on both sides of the inequality symbol. Well, I can't have variables on both sides, so I must move them. It doesn't matter which, since they're the same. So I'm going to subtract 6x from both sides. And what I end up with is negative 5 is less than or equal to 40. And I have to ask the question, is this a true statement? Is negative 5 less than or equal to 40? And indeed it is. So the answer to this question would be all real numbers. I could put any number in for x and I would get a true statement. To graph all real numbers, you use a number line and fill out the whole number line. Now, if I had solved this and I'd gotten a false statement, then it would be no solution. All right, let's take a look at this first one. I don't have any distribution or combining like terms or variables on both sides. So I'm just going to use inverse operations and solve by adding 6 to both sides. And I get negative 7r is greater than or equal to negative 56. Then I'm going to divide both sides by negative 7. But I'm going to, heads up, I just divided. So did I divide by a negative? Yes, I did. So it's important that I remember I have to flip my inequality sign. So it is r is less than or equal to 8. And I'm going to solve that. Graph it with a closed circle shaded to the left. Now, let's take a look at this one. I'm going to add 6 to both sides. And I get x divided by 4 is less than 21. Well, x is being divided by 4. To get rid of that 4, I must do the inverse, which is multiply. Multiply both sides by 4. Was it a negative 4? No, it wasn't. So I did not have to flip my inequality symbol. And I got x is less than 84. Now notice there is no less than or equal, so I'm going to use an open circle and shade to the left. Now, I go through this pretty fast. So if you need to stop the video, pause the video, do so at any time. All right, let's take a look at this one on the left. The first thing that we're going to do is distribute. And notice after we distribute that we have some like terms, 6x and negative 10x. And so I need to combine those like terms, and combine means add together. So 6x plus negative 10x is going to give me negative 4x. And then I'm going to bring down my plus 8 greater than or equal to 15. Now I'm going to subtract 8 from both sides. And then to get rid of my negative 4, I'm going to have to divide by negative 4. Now, again, I'm dividing. So anytime I multiply or divide, I have to say, did I multiply or divide by a negative? And I did. So I'm going to have to flip my inequality symbol. And it will now say x is less than or equal to negative 7/4. I'm just going to leave it as negative 7/4 on my number line. But I'm going to go ahead and put it in my calculator that that's a negative 1.75. So I know it's between negative 1 and negative 2. It has an equal sign on it, so I'm going to use a closed-in circle. I'm going to shade to the left. All right, let's take a look at this one. The first thing we're going to look at is there's no distribution, but I do have some like terms. 2x plus 4x gives me 6x minus 8 greater than or equal to 12x. Now I have variables on both sides. I can't have that. So I'm going to move my smaller variable if I can, and I can, so I'm going to subtract 6x from both sides, and I get negative 8 is greater than or equal to 6x. Now I'm going to divide both sides by 6, but I have to ask my question, am I dividing by a negative? No, I am not. I'm dividing by a positive 6, so I do not have to flip my inequality symbol, but I do have to reduce this fraction. Instead of 8/6, I'm going to say negative 4/3. Now, notice how my x is on the right side. Remember in our previous videos we said, anytime we end up with this, let's rewrite this. Let's put our x on the left. Let's put our number on the right. And then write our inequality statement the same by pointing it at the same thing. Notice up here, the inequality is pointing to the x. In my rewrite, it must point to the x as well. So it kind of just flips the whole inequality. Then it makes it super easy to graph. I put my negative 3/4 in the middle, which is the same as negative 1 3/3, or 1.33. And that tells me I've got a negative 1 on one side and negative 2 on the other. It is a closed circle, and again, I'm shading to the left. Lots of shading to the left there. All right. You are going bowling with friends, and you have at most $30 to spend. It costs $7 to rent shoes and $2 per game. At most, how many games can you play? Okay, well, I know I have $30, and I know that's the top amount of money in my pocketbook. So everything else has to be less than or equal to that. Now, to bowl, you just rent shoes once. So I've got the 7. And then also I've got $2 every game. And let's call games G. So I've got plus 2G. Now I can solve this, and I can subtract 7 from both sides, and I get that 23 is greater than or equal to 2g, divide by 2, and this time I am going to turn it into a decimal, and I'm going to say 11.5 is greater than or equal to g. So let's do the same thing here. Let's rewrite this. So my g's on one side and my 11.5 is on the other. Notice it was pointing toward the g here, so it's still got to point toward the g. And this says that I have to play less than 11 and a half games because I don't have money. I don't have enough money to play 12 games. So for full games, the most games I can play is 11. I think you have the information you need to start your homework.